Hello friends, let's design the schematic and PCB layout for the Astable Multi Vibrator using IC555. It's a timer IC. So this is a deep trace software where we can complete our schematic, and by porting the particular schematic we can go for it designing of its PCB. So let us start with the designing of schematic. So this is a grid structure which is observed on the screen. If you just click and scroll up and down using the wheels on the mouse, it allows us to zoom in and zoom out. Along with that, if you want the plain screen without grid structure, that option is also there. So preferably I will go with the grid structure, so it helps us to do the connections. Now starting with the basic components. Actually basically Astable Multi Vibrator to be designed using IC555 will be using here two resistors R1 and R2, one capacitor C, one resistance at the output along with the light emitting diode. So the working of Astable Multi Vibrator is wherein LED on and off. LED is made on and off automatically by a delay which is set by the values of resistors R1, R2 and capacitor C. Starting with initial values with the components. Now as soon as I see, this is a component list. In the component, if we click at the general option, general non-IPC, then there are various components, capacitor, then followed by few diodes, LEDs, resistors. So from that I will pick the first member capacitor. So as soon as click it, we have the two options as a part of schematic, and the component how it would be looked when it is placed down to the PCB. So capacitor, I will pick the capacitor, place it here. Let us zoom in. The drawing the structure is, while it's similar to the way we use the multi-sim software. We will zoom out, we zoom in. Capacitor is visible. So this is a capacitor. Along with that I will choose one more resistor. Resistor, okay, the first component resistor. Again this is the component how it looks to be, resistor. We require 3 resistors. I will make the 3 copies. You can make the escape, or once you select the components on the screen you can just place the enter button. Now what else is required? Along with this, IC is also required. So for selection of the IC, I will choose it. It's a filter option. If you don't know from which group or from which component family we should go for the selecting the IC, so I will type here 555 IC, and if I press here I will start with NE if possible, NE 555 IC. Let us see what happens if I apply the filter. Yes, so the component is identified. I will stop the filter. So the component has two parts. One is a schematic of the respective component and its PCB footprint. So it is in two forms, this one and this. If I go with this schematic, so we'll choose this schematic for the further connections for the circuit diagram. Now along with this, ground connection and power supply is also required. So net ports, it gives me the value of power supply of desired value. So power supply, along with that ground connection is also required. So ground connection, yes, we will select the 2 copies of ground connection. So we are left with, so one capacitor, 3 resistors, ground connection, VCC, one light emitting diode LED is left to be connected in the circuit. So let us pick the component as well. So in the general components, I have just now seen LED. Yes, it's an LED. So this is schematic and symbol of the LED, and this is its footprint, how it would look in the PCB design. Now this is now only just the interconnection of components is required. The way we do the connections in the multisim, similarly we can do. Just select the components. If you make it Control R, so it will allow us to do the connections. You can press the escape if you want to undo the action or selection. So Control R would rotate the resistance value. Now the required components R1 and R2, R3. Suppose R3 is a resistor to be connected in the output, so I can change its value. So its value is not mentioned here, so I will make its value as a 1000 ohm and I will say OK. So this is the way how we can specify. As soon as you change its value is observed in the design manager box. See R3, it is of 1000 ohms of 1K or 1K value. Similarly, we need to change the values of R1 and R2. So R2, this is again of, let us keep it of 1000 ohms only, and R1, one more resistor which is required, it's of 470K. 470, K means 1, 2, 3. Okay, fine. So these are the three resistors. Capacitor, I will choose of the value 1 microfarad. Capacitor, so let us choose of 1 microfarad. We could take directly. Capacitor of 1 microfarad. LED IC 555, power supply, let us choose the power supply. 9 volt supply is required, so we can change it to the value of the desired value. So these are the components that are required for the designing of the schematic. So now I will interconnect all these components. Components can be interconnected very similarly to the way we do the connections in the multisim. So one component I will show you. From the output side, we need to do the connections of R3. Let us say R3 is the resistance which is in the output port or the output terminal. I am connecting it to the output terminal. So this is a limiting resistor along with the diode LED. So I will rotate the LED. And ground connection. So even we can just rotate this so as to reduce the required space. So I will choose to do the connections like this. And for doing the interconnection of the components directly, if you go to the terminal and click here, it will allow us to do the connections. Accordingly, I will complete the connections of the circuit as per my circuit design. So the schematic is designed, it's just the interconnection of the components with designed values. This is with we are ready with the schematic now. We need to save this schematic circuit. So I will save this schematic, Astable Multi Vibrator. I will call this as Astable Multi Vibrator. Okay, and let us save it. Now once the schematic is saved, now let us go to the PCB layout part. Deep trace, it allows us schematic with the different screen, and we will go for the PCB layout. So if you go to the tab from the installed setup, PCB layout, so here we can open and link to the particular schematic. So file, renew layout from the schematic. So this in the file menu, this option renew layout from the schematic will allow us readily available designing of a layout for the respective schematic. So from the renew layout from schematic, I will click the my components option. So in the my components, recently stored circuit or Astable Multi Vibrator, open. So automatically it has designed this layout. So this is the screen with the PCB layout. So this is our IC 555. Then so pin number 1, 2, 3, 4, 5, 6, 7, 8. So 8 and 4 are shorted. So we can just cross check here the connections. Connections are visible. Even this is also available with, if we want, it's also available with the grid structure. So how the connections are done? So we have seen earlier 4 and 8 were shorted and it was provided with the VCC connection, and ground is given to the pin number 1. So this is just, it shows here as soon as we go with the pointer to the respective pin number, it shows it's a ground pin. This is the VCC pin, discharge pin, then threshold voltage pin, then control voltage, pin number 5. Recently we have not connected the pin to either of the connections. Then reset pin, accordingly these pin connections are made. This is possible with automatically designed PCB. So here now this is what layout we are getting. So these are the connections, how it looks. Now actually we can adjust it manually. So the software has done the adjustment as per the schematic designed by us. So 2 resistors, 3/3 resistor, R1, R2, R3, light emitting diode and the capacitors. Even we can interchange if we want, we can flip. Okay, so I can also show here. Here also there is option of rotating. We can do the connections or we can place it wherever we want as per our logical understanding of the locations. Now by the time right now I will keep it as it is. But here we can see its 3D view. If I just click on the 3D option, so it will be searching for the 3D models within the installed software and it will give us the look how it would look once the PCB is designed. Yet we have not designed any tracks, but it is showing just the interconnection of components, how this is connected. So we'll get such a message attached with respect to the 3D models, and then we'll be observed with 3D structure. It is nice to see how it would look when the PCB is designed. It will take some time. So this is how it would look. So yet I have not set any borders, so it is showing here. So this is the components, how it would look. So right now from the libraries, 3D model for the light emitting diode is not available. If it's not available directly, you need to download it as a part of the library. So this is the IC, capacitor, 3 resistors, how it would look. So this is where the PCB. So reset view to the normal view. So this is how the connections would look. With the left mouse, just press the mouse, keep it pressed and just drag it up and down. Then we'll be able to observe such a connection. This is the back end. So pin numbers, how it looks like. I will close this up. We'll go back to this view. Now from this, after this, what is our objective is we have to design the tracks or the actual layout. So while designing the tracks, there are options. If you go to this, route manually is also their option. So if you do the routing manually, if you click it here, from wherever the connections we want to do the connections, suppose I want to do the connections from this point, I will go here, come down and do the connections here. So manual routing is also possible wherever the connections are required. Suppose I need to do the connections, I will come from this side, do the connection. So manually routing is also possible. Only thing is overlapping of the tracks should not be there. It should be done properly. So by the time what I will do, I will choose the option of auto routing. So we can also delete what we have designed. So cancel. So this was just for purpose. Even if you just right click here and we can change the width of the layout as well. So I will select it right now by the time and delete the manually routed. As we are designing it for the first time, I will prefer to go with the auto routing option. So auto routing option, along with that, so this icon indicates place board outline. So we can place the outline of the board, PCB board. We can edit this as well later on. So we will choose a rectangular box here. Okay. Once it is done, so if you want to enlarge, we can just use this corners and reset it to desired value. But important part is now if I go for 3D structure, now it shows along with the 3-dimensional diagram. Yes. So this is how it looks. So on the back side it would look like this, and this is with the PCB board with a green background. So in continuation with this, we'll continue for the designing of the